Welcome my students and esteemed viewers. In today's class, we are going to investigate the various properties of a particular production function, that is Cobb-Douglas production function. In the very previous class, I did explain the various properties or the features which an ideal production function should have, and there were probably 8 or 9 properties. Now the same properties are going to be shown or proved with the help of a very famous production function, that is Cobb-Douglas production function. And this Cobb-Douglas production function is absolutely a function of K by L. Before I start to investigate its property, let me explain that after this production function, and another production function was given in economics by 4 economists, Arrow, Chenery, Minhas and Solow, and this production function is known by the CES production function, constant elasticity of substitution production function. I'll explain one property of this one, the last one, that is its elasticity of substitution is 1 by 1 plus beta, that I'll prove in today's class. Anyway, let us come on the Cobb-Douglas. Now this Cobb-Douglas has this A is known as efficiency parameter. I'll explain its meaning. K and L are the factors, this alpha and beta are the parameters, and sum of these two parameters alpha and beta equals 1. Now this A is efficiency parameter. This implies that for any unique combination of factors, larger value of A will lead to larger level of output. In more simpler terms, enhancement of A will shift the production function upward. In this case, at L1 amount of labor, we are having Q1 production. Amount of labor remains the same, but if value of A increases from A1 to A2, this shifts the production function upwards, and now with the same amount of labor we are having more amount of Q2, the output. This is the value and this is the importance of A. This is what A means. In simple words, we say that, well, A is a constant state of technology anyway, but this has this efficiency parameter. This means now its properties. First, CD shows constant returns to scale as it is linear and homogeneous. Q is A, K to the power alpha, L to the power beta. It is known that alpha plus beta is 1. So for finding its returns to a scale, we are supposed to calculate degree of homogeneity. So what we do, we multiply both variable by a constant lambda A, lambda K to the power alpha, lambda L to the power beta. Lambda is here and it is A K to the power alpha, L to the power beta, and this is lambda, alpha plus beta is 1, and this is Q, hence linear homogeneous, and this stands for constant returns to a scale. Constant returns to scale. Yes. Now secondly, we should investigate its productivity, that is a factor productivity. What would be factor productivity and how it could be expressed and shown. So second property is average product and marginal product are the functions of factor ratio, that is K by L or L by K. Now we have the production function Q A k to the power alpha L to the power beta, more precisely A to the power alpha L 1 minus alpha. Now average product of labor, that is Q by L. So A k to the power alpha L to the power beta and L this can be written as A k to the power alpha L to the power 1 minus alpha divided by alpha. This alpha is taken into the denominator. So A k to the power alpha and L 1 minus 1 plus alpha. So it is A k alpha by L alpha, and hence A k by L raised to the power alpha, and it is the function of k by L. Now marginal product of labor, that is delta Q by delta L. This has to be differentiated with respect to L. So 1 minus alpha A k to the power alpha L to the power 1 minus alpha minus 1. Now 1 minus alpha A k to the power alpha, and here we do have L to the power minus alpha. If it is taken into the denominator, it becomes L to the power alpha. So 1 minus alpha A and k by L raised to the power alpha, and so it is a function of k by L. Now average product of capital, that is Q by K. So A k to the power alpha L to the power 1 minus alpha and divided by k. K should be taken into a denominator and L is being brought into the denominator. So what happens? A k to the power alpha minus 1 and L is alpha minus 1. So it could be written as A k by alpha raised to the power alpha minus 1, and hence it is a function of k by L, and MPK delta Q by delta K alpha A k to the power alpha minus 1 n to the power 1 minus alpha. Once again alpha should be brought into the denominator. So K alpha minus 1 L alpha minus 1. So alpha A and k by L alpha minus 1, and hence once again it has become the function of k by L. So this way this could be shown that the average and marginal products of these two both factors are the functions of the factor ratio k by L. Now the third property regarding the respective shares of the factors in total product, because K and L are contributing in the production, so what shares they should have in the total product. So number 3, respective shares of factors in output. Mind it that when we shall calculate this thing, we will take it granted that factors are paid according to their marginal products. So share of K in Q is K into MPK by Q. This is the total payment to the capital and this is the total product. So K delta Q by delta K, and this is Q K alpha A k to the power alpha minus 1 L to the power beta, and divided by A k to the power alpha L to the power beta. If K is absorbed here, this minus will disappear. So finally we shall have alpha A k to the power alpha L to the power beta, A k to the power alpha L to the power beta, and hence it is alpha. Yes. So the exponent of capital is its own share in total output. Now share of L in Q, that is total payment to labor divided by total output. So L into delta Q by delta L by Q. So L beta A K alpha L beta minus 1 divided by A K alpha L beta. This L is taken to that side, this L, so this minus sign will vanish. So beta into A K alpha L beta, and here we have A K alpha L beta, and hence it is beta. So one of the final results of Cobb-Douglas, that respective powers of capital and labor are their own shares in total output. Now number 4, Q is a function of K and L. So Q will have its elasticity with respect to capital and labor. When we shall calculate elasticity of Q with respect to K, that will be capital elasticity, and when with respect to L, that will be labor elasticity. So capital elasticity is marginal function by average function delta Q by delta K Q by K, that is alpha A K to the power alpha minus 1 L to the power beta, and A K to the power alpha L to the power beta divided by K. So alpha A K to the power alpha minus 1 L to the power beta, and this K is being taken to here, so it will become alpha minus 1. So A K to the power alpha minus 1 L to the power beta, hence it is alpha. And labor elasticity, marginal function by average function delta Q by delta L, Q by L, it is beta, and A K to the power alpha L beta minus 1, and A K alpha L beta by L. This L is being taken here, so beta A K alpha L beta minus 1, A K alpha L beta minus 1. So once again it is beta. So this alpha and beta is not only the shares of K and L in Q, rather apart from that, this alpha and beta are the respective partial elasticities of these two factors with respect to Q. Now fifth property, the shape of isoquants. Isoquants generated by this Cobb-Douglas is a well-behaved isoquant. It well-behaved isoquant. So this is a downward falling as well as convex of nature. So it must be 5 or 6. Isoquant of CD is downward sloping and convex from below. Now for an IQ to be downward sloping, it must have a negative slope. So for downward sloping, we have to show dk by dl negative, and for convexity of the curve, we have to show second derivative as positive. Now dk by dl is defined as mpl by mpk. I had shown in the last class. So this is minus delta q by delta l and delta q by delta k minus beta a k to the power alpha l beta minus 1, and this is alpha a k to the power alpha minus 1 l to the power beta. Now k is to be taken in the numerator and l is brought into the denominator. So what happens? Minus will remain, constant is beta by alpha, and what remains is k alpha minus alpha plus 1 and l beta minus beta plus 1. So we are left with negative slope of isoquant, that is minus beta by alpha into k by l, absolutely negative. And for second derivative to be positive, this first derivative has to be differentiated once again with respect to L. Now when this is to be differentiated with respect to L once again, then this minus beta by alpha into k, these all are constants, simply 1 by L has to be differentiated, and the differentiation of 1 by L is minus 1 by L square. So this is minus beta by alpha into k into minus 1 by L square. So minus minus neutralized. So beta by alpha into k by L square, absolutely positive. So IC of this Cobb-Douglas is a downward sloping and convex from below. Now property we are so that if Q is a function of K and L, then the marginal product of these two factors has been defined as MPK delta Q by delta K, and that is Fk. And marginal product of labor is delta Q by delta L, that is FL. These two are positive. Now what we have to show that these two are diminishing in character, that is of such curves. Yes. So MP curve having a negative slope, so we have to show FKK negative and FLL negative. Now Q is A k to the power alpha, L to the power beta, where alpha is positive fraction and beta is positive fraction, both positive, both less than 1. So MPL is beta a k to the power alpha, L beta minus 1. So FLL, once again this entire has to be differentiated with respect to L. So beta into beta minus 1 A k to the power alpha and L to the power beta minus 1. So this is beta minus 1 A k to the power alpha, L to the power beta minus 2. Now this quantity lying within the bracket makes the entire term negative because beta is less than 1, and here we have beta minus 1. This makes this term negative. Similarly, Fk, marginal product of capital alpha A k to the power alpha minus 1 L to the power beta, and so Fkk is alpha into alpha minus 1 A k to the power alpha minus 1 L to the power beta. Once again this alpha minus 1 makes the entire term negative. So both factors have the diminishing productivity, and for that we have to show the slope of the MP of both of the factors as negative. Well, students and viewers, in today's class I have explained and proved and as well as shown 6 properties of Cobb-Douglas. Now remaining 3 properties I'll show in the next video, and in the same video I'll show a longer work of elasticity of solution of CES production function. So for today's class let it be here. That is all for today. In next class I'll conclude today's discussion. Thanks.